So we're moving on to a new topic, and that new topic is using proof to talk about congruent triangles. But before we can actually get started with that, we have to kind of define some of our terms first. So we're just going to take a basic introduction into triangles, some facts about them, and then some properties. So the first question is, how can we classify triangles? So we're going to classify them by two different criteria. Criteria number one is going to be by their sides. So what different types of triangles can I have if I classify them by their sides? Well, the first one is what we call scalene. So scalene triangles are triangles that have no congruent sides. No congruent sides. So for example, I can draw a scalene triangle here. It's a pretty good scalene triangle. I missed a little bit. Try that again. But none of the sides are congruent to each other. Okay, so I don't have any lengths marked. I'm not going to assume that they're congruent to each other, so this triangle will be scalene. The second one that I can talk about is what's called isosceles. So isosceles triangles are triangles that have, and this is really important, but have at least two congruent sides. At least two congruent sides. And maybe I should follow some of the good diagramming habits I have. I should label these A, B, C, D, E, F. Okay, so if I want to talk about an isosceles triangle, I need to talk about two of the sides being congruent, so I should mark them. In this case, I have that side DE and side EF are congruent to each other. This at least two we're going to come back to in a second here and say why it's so important, but I need at least two sides to be congruent. And so then my last one is equilateral. And so what equilateral triangles are triangles with three congruent sides. So for example, this one here looks good enough, where all the sides are congruent to each other. Okay, so the reason that this at least two part is important is that it's worth noting that equilateral triangles are a subset of isosceles triangles. Now, if I want to give a triangle the most specific name I can, I should call it equilateral whenever that's the case, but an equilateral triangle is also a type of isosceles triangle. So this is how I classify. These are my three potential options. I really don't have any other options for when I have triangles and I classify them by their sides. I can either have no sides congruent, at least two sides congruent, or all three sides congruent. Those are my only options. I can also classify these by their angles. So option number one is that I can have what's called an acute triangle, which would be with three acute angles. So this would be something like this. Maybe extend that a little bit more. There you go. Okay, so this is an acute triangle. All three of these angles are acute. It's kind of hard for me to, unless I actually give these measures, to label them in such a way that you know that they're acute, so we're kind of going it based on what they look like. My next one would be a right triangle, which specifically has one right angle. And so when I draw this one I can denote. I should mark that this is a right angle here. JKL N N O. And so I need to say that this is a right angle, and so I can only have at most one right angle in a triangle. Next, I could have then my third option, which is I could have one angle that's obtuse, so one obtuse angle. And again, this is another one, since I don't really have a marking for obtuse, I just kind of have to go based off of what it looks like. So this would be an obtuse triangle, PQR. This would be obtuse. And last but not least, I have a special case, which is equiangle. equiangular, which is 3 congruent angles. And once we know a little bit more, we can actually talk about what exactly those measures are, and the fact that this will actually be a type of one of these others, and it's going to be acute. STU. Okay. So these are the two ways that I can classify triangles, either by their sides or by their angles. And these are all my possibilities. I really can't create a triangle that is not acute, right, obtuse, or equiangular. I can also not create a triangle that is not scalene, isosceles, or equilateral. Every triangle that I make has to fit into these categories here. In fact, they'll fit into 2 different categories, one based on sides and one based on angles. And we'll actually talk about later how some of these go together. For example, I can't have a a right equilateral triangle, for example. Only some of these go together, but every triangle I make will have one of these 3 classifications and one of these 4 classifications every single time. Okay, so that's how I classify triangles. Next, we're going to define how I'm going to talk about their angles. So if I talk about a triangle, and let me just give a triangle to reference here. So if I have a triangle, it's a pretty good triangle, the interior angles formed by the side, the interior angles are the angles formed by the sides of the polygon. So each of these 3 sides, I'll label them again, they form 3 interior angles. And so angle A, angle B, and angle C would be the interior angles. The exterior angles are not what most people would probably think are this entire outer area. That is not the exterior angle. The exterior angle is if I were to extend one of these sides, the exterior angle would be the angle that is then a linear pair with one of the interior angles. So that's why my definition is exterior angles are the angles that are linear pairs with the interior angles. Okay, so I actually have for each interior angle, I actually have 2 exterior angles that go along with it. Now obviously which I pick doesn't matter because they'll end up being vertical angles, but each of these interior angles will have 2 exterior angles that go along with it. And so that's how we refer to them. And once we have names for them, we can talk about an interesting fact, which is this. So the first theorem that we're going to take a look at, and honestly this is probably the first theorem that is interesting, because every theorem we've done up to this point has been more or less obvious facts, but this is probably the first one that you probably knew was true but didn't know why, and that is the triangle sum theorem. Triangle sum theorem says that the sum of the measures of the interior angles of a triangle is 180 degrees. So if I take any triangle and I add up the measures of the 3 interior angles, what they will always sum to be is 180 degrees. And so that's a totally non-trivial fact that we will of course prove, but this is kind of one of our starting points. A lot of these things will, or a lot of the things that we talk about will be based off the fact that we know that the sum of the interior angles is 180 degrees. Now one thing I do want to point out is that what we're not going to say is that a triangle is 180 degrees. A triangle is not 180 degrees. Only angles can have degree measures, and in this case the sum of the 3 interior angles will be 180 degrees. And then much later on we'll talk about the exterior angles and what they sum to be. But we're just starting off with this. So this is something that we'll prove. It's going to be probably one of the more interesting proofs that we do, and that really proves something that is useful and is interesting to us. But we'll do that later.